Welcome to Arid Online Academy. We are presently on lesson 3 of chemical formula, and we'll be focusing in this lesson 3 on empirical formula and molecular formula. Empirical formula and molecular formula. By the end of this lesson 3, you should be able to define empirical formula and molecular formula and use the definition to differentiate between the two types of formula, and you should be able to give examples of empirical formula and molecular formula. So let's look at the first example. This particular compound is called a propane. It's a propane. It's a propane. And so the name, okay, propane. Now, looking at this particular compound, what are the types of atoms present in this compound? This compound consists of carbon and hydrogen. We can see you have carbon, carbon and hydrogen present in the compound. So the types of atoms present, we have carbon and hydrogen. So the next thing we would like to do is to count the number of carbon present. So if you look at this, we have 1, 2, and 3. We have 3 carbon atoms present, and altogether we have 6 hydrogen atoms present. 6 hydrogen atoms present. So we can deduce two information from this particular formula represented here. We can tell the types of atoms that this particular compound propane contains. It contains carbon and hydrogen. We can also tell that this particular compound consists of 3 carbon atoms and 6 hydrogen atoms. So this kind of representation, this kind of formula that tells us the types and the actual number of atoms present in a particular compound is called a molecular formula. Molecular formula. So we can say that a molecular formula shows the actual types and number of each atoms present in a compound. So molecular formula tells us the actual types and number of each atom present in a compound. Now let's look at the empirical formula. Then what will empirical formula mean and what does it represent? Okay? Now, having seen that this particular compound contains only carbon and hydrogen, so we will be interested in finding the ratio of the constituent element in this particular compound. Carbon is present, we have 3, and hydrogen 6. But the simplest ratio, the reduced ratio of carbon to hydrogen, how do we find that? Okay, a number that can be used to divide 3 and 6 to give us the simplest ratio will be 3. So if you do 3 divided by 3 and 6 divided by 3, 6 divided by 3, we will be getting 1 and 2. We'll be getting 1 and 2. So invariably the ratio of carbon to hydrogen will be CH2. CH, that is C1H2. But because it is 1, we just write C and H2. So, comparing the two formula together, your molecular formula, which is C3H6. If we compare the two formula, this is the molecular formula for this particular compound, and this is the empirical formula, while this is the molecular formula. We can see that the molecular formula tells us the actual number of carbon present and the actual number of hydrogen atoms present in this particular molecule, propane, while the empirical formula tells us just the ratio of carbon to hydrogen, the ratio of carbon to hydrogen. So, empirical formula shows the ratio of the constituent element in a particular compound, while the molecular formula tells us or shows the actual types and numbers of each atom present in a compound. So let's look at one more examples. Okay, now let's look at a compound called hydrogen peroxide. That's the compound present in your mouthwash. Okay, hydrogen peroxide. Hydrogen peroxide has a formula H2O2. H2O2. So the molecular formula for hydrogen peroxide therefore is H2O2, because one molecule of hydrogen peroxide consists of made up of 2 hydrogen atoms and 2 oxygen atoms. So the formula of this compound, its molecular formula, it's H2. You use subscripts to show in the formula the constituent, the number of the constituent atom, O2. Okay, so now discussing its empirical formula, we want to show the simplest ratio in which hydrogen is present with respect to oxygen. So we have 2 hydrogen atoms and we also have 2 oxygen atoms. So to show the ratio in which these particular elements are present, I'll divide this by the simplest number, the nearest whole number that can give us the simplest ratio. So 2 will be divided by 2. I mean, these 2 here divided by 2, and of course that gives 1. Oxygen present 2. Okay, so dividing it by 2, that also gives what? 1. So the ratio of hydrogen to oxygen, okay, that we have here, it's actually ratio 1 to 1. So the empirical formula for hydrogen peroxide therefore will be HO, because the ratio of hydrogen to oxygen is ratio 1 to 1. Ratio 1 to 1. So you can see again here that the empirical formula just shows the ratio in which the constituent atoms are present in a compound, while the molecular formula tells us the actual number of the constituent atoms present in a particular molecule. Another example, this is another compound. This is ethanoic acid. Ethanoic acid. So again, what are the types of atoms present in this particular substance? This is ethanoic acid. Okay, So the types of atoms present, types of atoms, okay, present, we have carbon, we have hydrogen, and we have oxygen. Okay, so the number of carbon atom present in one molecule of ethanoic acid, we have 2 carbon atoms present. Here, 2 carbon atoms are present. So we need to find out the number of oxygen atoms present. So we have 2 carbon atoms present. Okay, hydrogen we have 1, 2, 3, and 4. Okay, so we have 4 hydrogen, 2 carbon atoms, and of course we have 2 oxygen atoms. So the empirical formula, or first let us find the molecular formula. First, the molecular formula therefore will take into consideration the actual number. So we have carbon and 2 carbon atoms, then we have hydrogen. Okay, we have 4 hydrogen atoms, we have oxygen, we have 2 oxygen atoms. So this represents the molecular formula of ethanoic acid. Now its empirical formula, so let's look at its empirical formula. We have 2 carbon atoms present, 4 hydrogen atoms present, and 2 oxygen atoms present. So the ratio of carbon to hydrogen to oxygen, 2, 4, 2. But the simplest ratio here, how do we find that? We find the simplest ratio by dividing these numbers by the smallest of the numbers. So we have divided by 2, 4 divided by 2, oxygen divided by 2. So we have 1 ratio 2 ratio, oh sorry, that should be ratio 1. Okay, ratio 1. Okay, so the empirical formula therefore will be C1 H2O1. So usually if the empirical formula, any atom exists one time, so what you do basically is to write carbon without bothering to write 1, hydrogen 2, and oxygen 1. So this is the empirical formula of ethanoic acid, while this is the molecular formula for ethanoic acid. It's pretty simple, isn't it? Now, is it possible? Is what possible? What is possible? Is it possible for the empirical formula of a particular compound to be the same as its molecular formula? Yes, it is possible. Looking at this compound, this is propane. This is propane. So for propane, we have carbon and hydrogen as the constituent element. We have 3 carbon and we have 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogen. Okay, so we have, that is molecular formula will be C3 and H8. Okay, now looking at its empirical formula, this is its molecular formula. Okay, molecular formula. Now looking at its empirical formula, and how do we get that from previous example? We'll find the simplest ratio of the atoms in the particular molecule. So in this case now, carbon to hydrogen is ratio 3 to 8. Okay, there is no other formula that we can use, there is no other number that we can use to divide this to give us the simplest, another simplest whole number ratio, or a simpler whole number ratio. So the simplest whole number ratio that we can get for this compound is C3H8. So the empirical formula is C3H8. So you can see that both the empirical formula and the molecular formula are the same. So it is possible for compounds to have the same empirical formula and molecular formula. Absolutely possible. Now, further examples on this, if you look at water, okay, as a particular, another example of a molecule that you are familiar with, water, okay, its molecular formula for water is H2O, because for every molecule of water you have two hydrogen atoms combining with one oxygen atom for every molecule of water. So its empirical formula is will also be the same as its molecular formula. The simplest ratio we can get here, hydrogen to oxygen 1. The simplest ratio we can get is ratio 2 to 1. So empirical formula is also H2O. So it is possible for a particular compound to have the same empirical and molecular formula. Okay? Other possibility, it is possible for different compounds to have the same empirical formula. It is possible, I state that again, for different compounds to have the same empirical formula. For example, looking at this compound C3H6, this is its molecular formula, while this will represent the empirical formula. Okay, the simplest ratio for this particular molecule will be 3/3. That's for carbon and hydrogen. Okay, and 6/3. And so we will be getting 1:2. So its empirical formula will be CH2. CH2. Okay, so let's look at another compound. So it is possible for different compounds to have the same empirical formula. So what have we learned in this lesson? We have been able to see that the molecular formula shows the actual number and types of each atom present in a particular compound. Okay, but the empirical formula just shows the simplest ratio. Okay, a simplest ratio. A given example to recap: molecular formula of hydrogen peroxide is H2O2. Why the empirical formula will be HO. This just tells us the ratio of hydrogen to oxygen is ratio 1 to 1. While the actual number of hydrogen present is 2 and the actual number of oxygen present is 2. Catch you in the next lesson on empirical formula. I would like to advise that you like and share and subscribe to this YouTube channel.